Let's talk about permutations. A permutation is an arrangement of items where the order matters. And perhaps it might be more clear to say that the position matters, that each position has a distinct slot. So having a object that's in a different spot is a different arrangement altogether. But let's take a look at the permutation formula. The general formula for permutations of n items taken r at a time is, you can see it in this function form, or you can see it with this subscript n, capital P, and subscript r, where this is equal to n with an exclamation point. We'll soon know what that means here. And then over top of this bracket, n minus r with this exclamation point. So n is the number of items that you start out with, r is the number of items that we want to arrange, and then n with this exclamation mark can be read as n factorial. Now n factorial is the product of all positive integers starting at 1 going all the way up to n. Now it's actually better to think of it as n factorial being n and then multiplied by 1 less than n and then 1 less than that one, all descending all the way down to until you get to 1. So let's take a look at factorial notation then. If we take a look at this factorial notation, it represents the total ways to arrange n distinct items in this permutation idea. If all the items were used, so if all n items were used, then we could say n factorial represents the arrangement of all of them. But since we only want to arrange r items out of n, a certain number that's less than n, we're going to divide by n minus r in brackets factorial to eliminate the arrangements of items that are not selected. And we'll talk a little bit more about that a little bit later. But the factorial notation is n factorial represents the product of all positive integers from n times n minus 1 times n minus 2 and continue on going down by 1 all the way until you have that final product of 1. Now factorials are fundamental in combinatorics, algebra, calculus, probability, cryptography is an extension of it. Anyway, let's take a look at what the definition is. You can see it here. For a positive integer n, we have n factorial, and that equals n times n minus 1 times n minus 2 times going down by 1 all the way until you end up with 1. So we have an example here. Down here we can see that we have 5 factorial. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. That ends up being 120 altogether. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. And of course, 120 times 1 is 120. 3 factorial is 3 times 2 times 1 equals 6. So we can see that this n factorial is that number n times 1 less and then times 1 less than that all the way down until you get to 1. 1 factorial is 1, and just by the definition we want to say that the factorial of 0 or 0 factorial is equal to 1, and this definition will help with our working with factorials simpler and consistent, and when we use it we can perform some algebraic manipulations. Okay, so let's take a look at an example of permutations. So we have an example where we're arranging 5 objects at a time, but taking 3 at a time. So arranging 5 objects, but only taking 3 at a time. So we say that we have 5 items. We'll say the letters A, B, C, D, and E, and we want to find the number of ways to arrange 3 of them. So here in this case, we can say that n, the total number of objects, is 5, and how many we're taking at a time, this r, is equal to 3. So we use this formula. Here's the function, permutation function, but you could also have this 5, capital P, subscript 3. By definition, on our formula sheet, it says it's n factorial over n minus r factorial. So we have the number of objects, 5 factorial, divided by 5 minus 3 factorial. And in that case, when we simplify it, we can see that 5 minus 3 is actually 2 so 5 minus 3 in brackets factorial will become 2 factorial, and we have 5 factorial over 2 factorial, and 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120, and 2 factorial is 2 times 1. So in essence, we have 120 divided by 2, and it equals 60. Well, let's take a look in a little more detail. As the answer, we say, okay, well, there are 60 ways to arrange 3 items out of 5, or to arrange 5 items taken 3 at a time in order. Now again, in permutations, order matters. In combinations, it doesn't. If you haven't talked about combinations yet, then we'll soon get there, but the position matters in permutations. An object in a specific distinct slot is a different arrangement. So arranging A, B, C, having that order A in the first spot, B in the second, C in the third, is different than having an arrangement of B, A, C, where B is in the first slot, A is in the second, and C is in the third. You still have the same 3 letters, but the position actually matters. So where they are is important. Now the formula structure, where it says, well, we have to divide n factorial by n minus r factorial to account for only arranging r number of objects out of the n total items. So the big question then is, why divide by n minus r factorial? What is so important about that? Why do we have to do it? And I'm going to walk you through a process that may give us a hint on how we can think about it. So I'm going to move through this table here, and we'll say, okay, we do have 5 items that we're going to arrange, but we're only taking the first 3. So you imagine, let's do a full permutation. Let's arrange all 5, and then we'll just cut off the extra 2 letters at the end. Well, we can see that, of course, this table continues on forever. Not forever. There's 120 elements if we just do a full permutation of 5 elements. 5 factorial is 120. So there will be 120 different arrangements of 5 elements. But if you're not taking all 5 elements, if you're only taking 3 at a time, you can see in this first row, we have ABC with DE following it. Or you could have a different arrangement if you were talking about 5 elements of ABC with ED. You can see these 2 letters are switching. But in the case where you're only taking 3 at a time, then that means that this ABC actually has the same first 3 letters. And so in essence, when we cut off the last 2 letters, then we actually have the same arrangement, ABC, in that order, which is important. It's duplicated, it's repeated. And again here, if we have ABD, we have, if you're looking at all 5 elements, we have ABD with a CE, but still the first 3 letters are ABD. And again, ABD here, but if you're talking about the 5 elements, you have 2, a different arrangement, so it doubles up. And you can see that it happens for every single, where you have first 3 elements and then the last 2 will switch. So there's actually a duplicate every single time. Okay, so then if there's a duplicate, then what we need to do is cancel out that duplicate. Actually, having 120, out of those 120, there is a duplicate of each one, so actually we need to take out those duplicates. So we have to cancel that repetition of 2. So we have to take 120, divide by the number of arrangements of these remaining letters. So 120 divided by 2 factorial. So we have 120, or in other words, 5 factorial, the number of arrangements of arranging all 5 elements, and then canceling out all the repetitions that are caused by the arrangements of the letters that we did not select. Okay, if we could extend it, if there were 6 elements, then we would say we would arrange all 6 elements, so 6 factorial, but then if there were only 3 at a time, we would have to say, well, the ones that we do not select, then there's an arrangement of those 3 elements that cause repetitions. And so that would be, again, we would have 6 factorial over 3 factorial. And then it would say, well, continue this on. This would be, I think this is 720 divided by 6. I think this is 120. I'll have to check that. But anyway, here it is. if I can show you the full table here. Here's the full table of all 120 combinations, and you can see that you have ABC and ABC again, ABD and ABD again. It is a repeat, a double duplicate of the first three letters every single time, all the way through the 120 different permutations. Anyway, I hope that gives you an idea of why we have this n factorial over n minus r factorial, and you have a better sense of this bottom of where it comes from. This is the number of arrangements of the objects that you did not use, and because you're cutting those off, you're not selecting those, then it creates duplicates that we would have to cancel out. Anyway, to conclude, permutations are very important. Permutations are where the order of the items or the position of the items matter, such as arranging people in line, first place, second place, third place. Being in different places is a different arrangement. Ordered codes or determining possible outcomes in scenarios with distinct choices. The beginning path to cryptography. Anyways, permutations are cool, and I will see you in class.